Good day, Bashana. And once again, we're back together. And this time, we are looking at the last and final exercise in the series. We're looking at question 8. If you have not subscribed, please make sure that you're part of this channel. All right. And for all my grade 11s, we've already done all the exercises, right? From question 1 all the way up until question 7 in separate videos. And we are doing the final installment on this exercise. And I hope that this will actually seal the deal when it comes to proving identities. All right, let me stop yapping and let's get right into it. All right, so if I look at this, remember, by the way, I'm expecting that you should have tried it on your own first, okay? So please, if you haven't, just do that on your own. Why do I keep writing 8? So we've got 1 over cos of theta minus the tan of theta, okay? And this is all squared. And they want us to prove that this is equal to 1 over sine theta and 1 over cos of theta. Just like I did number 7, I want to give you 2 ways in which you could have, you can do this. Okay, I'm just trying to get that straight line there. So I've got 1 minus sine theta and 1 plus sine of theta. Right, now ladies and gents, I want us to try this one together. Right, so remember I said to you, we work on the left and the right hand side separately. Right, so what I'm going to do is firstly, right, on the right hand side, on the left hand side rather, so 1 over cos theta. I hope you guys don't have a similar problem like I have. You know, I always need to check first which one is my right and which one is my left. Yeah. Okay, so we've got 1 over cos theta minus the sine of theta. I said you convert everything into sine and cos. So this is all squared, right? So I'm working only on the left-hand side. Now, if you notice this, we've got, now if you notice there, we've got cos and cos as our LCD. So in this case, it only becomes just one fraction like that. So that would be cos of theta, right? So if our denominators are the same, we can just simply add the numerators together. So we've got 1 minus sine of theta, okay? But remember, this is all squared. Alternatively, what I can do is look at it as, okay, so that squared over this squared, right? The numerator squared over the denominator squared. I think that might serve us even better, right? So in this case, I've got 1 minus sine theta squared. Now, many of us would actually make the the mistake here of saying, well, this would be 1 minus sine squared of theta. Please remember, if I've got 1 minus sine theta times 1 minus sine theta, that will not result in 1 minus sine squared of theta. That will result in 1 minus 2 sine theta plus sine squared of theta. Okay, you can work it out and have a look at it. Okay, so please be careful of that. But I'm going to leave it in that format. Okay, and this is divided by cos squared of theta. Now remember, I said to you, when we've got a square identity, right? So for a square identity, that will give us, okay, so we've got 1 minus sine theta, 1 minus sine theta. Okay, deliberately I'm writing it in that way. But we've got this divided by 1 minus sine squared of theta. And this is the difference of 2 squares, ladies and gents. And what is informing this decision, right? Because I can see I already have 1 minus sine theta on the right-hand side. The only thing that I'm missing now is having the 1 plus sine theta. So how can I create that? I can say, well, this is going to be 1 minus sine theta into 1 minus sine theta, and this is divided by the difference of two squares. If I factorize that, that will be 1 plus the sine of theta times 1 minus sine of theta. And ladies and gents, you can definitely see how this and that will cancel out, and I ultimately have 1 minus sine theta divided by 1 plus sine theta at the end. And so what do you notice? Left hand side is definitely equal to our right hand side. We've proven the identity. Right. Now, there is another way in which we could somewhat prove that. Okay. What you could have done is to work from the right hand side. Okay. So once again, on the right hand side, you had that 1 minus sine theta over 1 plus sine theta. Now I showed you how, when we did question 7, that you can actually just make sure that, when you look at this, right, I ended up with cos squared of theta on the left hand side. So I can do that again by simply multiplying. Okay, I just want to have a bit of space. I can multiply there by 1 minus sine theta, and I can divide by 1 minus sine theta, so that it is seen as multiplying by 1, right, in this case. So that gives me 1 minus sine theta times 1 minus sine theta at the numerator. That will be, remember, our distributive law, 1 times 1 is 1, 1 times negative sine theta is negative sine theta, another negative sine theta times 1, that's minus sine theta, and finally negative sine theta times negative sine theta, that's positive sine squared of theta. Right, now notice at the denominator you've got the difference of two squares. I'm just going to write that down as 1 minus sine squared of theta, and when I add those two, I've got 1 minus 2 the sine of theta plus sine squared of theta divided by 1 minus cos sine squared of theta. That would be cos squared of theta. And you'll notice, ladies and gents, that this looks like what I had over there. Where is it? Right there. Okay. Right. So you can say, well, from that perspective, that is left hand side equal to the right hand side. Of course, you would have made some adjustments onto the left hand side. If you want to, you can get it right back to what it was originally, but I am going to leave it right here. And ladies and gents, I hope this has been helpful, right, in looking at proving identities. I am going to leave it here, but if you've got more suggestions of more questions that you'd like for us to look into, grade 11 questions, I'm more than happy for us to look at them together, and I will feature them onto this channel, and I'll make sure that I answer your questions. For now, I will see you guys again next time. We are going to be looking at trig functions. All right, we are going to be solving for trig functions using the general formula. So we will see each other next time. For now, I'll see you guys next time. Sharp, sharp.